So the question is, and it's brought to light, it's a good example of how I was saying that the technology gives us new insights into learning. It's brought to light by a device like this, because a computer simulation of a dentist situation of a human mouth is only a simulation. And even if every possible avenue is taken to make the simulation as true as possible, and by the way, that might not be the right strategy. Maybe it should be an enhanced human mouth where you can see through the teeth. Or, I mean, there's all kinds of interesting questions that can be asked. But even if it really is a faithful representation of the actual situation, what else is the student learning? Because obviously they can't just be learning what they're doing with the technology. We're expecting it to transfer. So this is a good example, I think. I haven't got time to say much more about it, but it's a good example of a genuine educational problem where light is beginning to be thrown because of the importance of designing a technology to achieve some learning outcome. Well, I said what flexibility is. Let me give you a couple of quick examples. Yeah, I've got 15 minutes. This is a project that's based in the University of Nottingham in the UK. Professor Mike Sharples, who some of you, I know I've heard his name mentioned in one or two contexts in the last day. And the idea is that students can investigate interesting things in the science, in the realm of science, by integrating mobile devices and by using those mobile devices as a way of sewing together different contexts in which the students live, so about their own bodies and their own lives, about the environment in which they live, and about the communities that they're part of. And here I think we will see some genuine advance around the world. We're beginning to see it a lot now. This project is in no way unique. We're beginning to see ways in which the fact that everybody has a machine that is more powerful than a supercomputer was 25 or 30 years ago. Everybody has one in their pocket. I realise it's not everybody, but it really is a huge section of the planet. I think we will begin to see really innovative ways in which that's being used. And I don't have time to say much about the project, but I just want to give you the headline, which is to do with this idea that I was talking about before, about complexity. Most of education, we have to rule out complexity, because complexity means that the way of dealing with complexity needs a huge amount of machinery. You need to know a lot of maths and science in order to make sense of an even half interesting question. One of the interesting questions that the Personal Inquiry Project is looking at with kids is, does traffic noise affect bird song? It's a really nice question. You know, it's one that interests kids. Kids are really interested in the environment. They're particularly interested in pollution, and noise pollution is obviously an important factor for kids living in cities. Everybody loves birds. But this is a really complex question that you really need some serious thinking about what variables are important, and you need to build a mathematical model. You probably have to have some big, powerful bits of mathematics in your toolkit to solve some of these problems that would emerge, unless you have computational tools that will assist you, and hopefully computational tools that are in your pocket. And so being able to handle complex situations is an important factor here, and I think again it's one that I want to flag as overarchingly important. And the same with hierarchies. The graphocentric curriculum worked extremely hard to produce hierarchies of knowledge. You can't learn this until you've learned this. And you can't learn this until you've learned this, this and this. And that makes some sense. If you only have a static technology and you really have exercise books, school books are the main medium of instruction, everybody has to have the same sequence. Once you've written it down, it is a sequence, whether you want to or not. But it really doesn't make sense anymore. And there are things that we can do. We know that people are capable of doing things in completely unheard of orders. my personal thing that I like to think about all the time, and I try and convince people with no success at all, is that we should teach students about acceleration before we teach them about velocity. Why? Because travelling at constant velocity is really boring and you don't know you're doing it. But turning around a corner in a car, everybody has the sensation and they know what acceleration feels like. So let's teach acceleration first. Why don't we? Because if you only have equations and graphs and pencil and paper, it's much too complicated. But if you have a computer, it's no more complicated to do it that way around. So I told you I get excited when I think about this example, but there are lots of other examples I can give you. I'm going to skip, because I know I only have a few minutes left. So let me jump to the question of inclusion. And as I said, inclusion is a very big issue for many of us all around the world, and it has multiple meanings. And I want to give you a general sense of a couple of projects where the one size for everybody really is doing a disservice to our students. And this is a really fascinating project. This is a project which is dealing with kids who have autism. And some surprising statistic, I think it's something like 1 in 20 students are on the autistic spectrum in the UK, and I can't believe there's anything special about the UK. It must be a worldwide phenomenon. Of course, it could be undiagnosed in many cases. But that means that in every one of your classes there are probably 2 kids on the autistic spectrum. And this project is building all kinds of tools, using collaboration between computer science and education researchers, all kinds of tools to help students to relate to other students through the medium of the technology. So, for example, students who have difficulty in reading eye movements and emotional responses of other human beings, if you enhance those responses with a computer, you can get them to react in ways that are very difficult for them. And then, of course, comes the transfer problem. Can they do it better when they're in non-technological situations? And the answer is nobody knows yet. This is a fairly new project. Here's a really, I love this little piece of, it's a little piece of video just for a few seconds. These avatars on the screen really are reacting to him. I love it when he walks off and they look around. Oh, there's nothing, okay, we'll go too. Just to give you a flavour, that you can, this is not revolutionary computer science, but I think we will see more of computers reacting, behaving emotionally. I think emotional computing is a huge area that is mushrooming now, and I think it has a lot of potential for us if we're interested in education.